Hey there, this is MathCamp321 presenting another video on a question like number 15 from chapter 8.1 from the book Geometry for Enjoyment and Challenge. If you can follow along the next example that I give, then you'll be able to go to section 8.1 of your book and do number 15. The question says, if 5 is a mean proportional between 20 and a number, what is the number? Now the first thing that I need you to know is that mean proportion is a synonym for something else. Mean proportional is a synonym for geometric mean. Now a geometric mean or a mean proportional is a type of average. And it's a little bit difficult to explain at first, but I'm going to give you a few simple examples which will illustrate the concept here. I'd like you to consider the set of numbers 3, 15, and 75. We can say that 15 is the geometric mean between 3 and 75, and I'll explain to you why that is. Using multiplication, to get from 3 to 15, we multiply by some number, and it happens to be 5. To get from 15 to 75, we multiply by some number, and again, it happens to be 5. If these two numbers are the same, then you've got a situation where the number in between is the geometric mean or the mean proportional. Let me give you another example. Let's consider the numbers 2, 6, and 18. We can say that the number 6 is the geometric mean or the mean proportional between 2 and 18. Again, using multiplication, to get from 2 to 6 we multiply by some number, and in this case it happens to be 3. To get from 6 to 18, we multiply by some number, and it happens to again be 3. Since these two multipliers were the same, we know we've got a situation where we have a geometric mean. So 6 is the geometric mean or the mean proportional between 2 and 18. Now, there's another way to think about this. We could figure out what the mean proportional is, or the geometric mean, by setting up a proportion. I could say 3 is to x, as x is to 75. Now you always want to put the geometric mean along the diagonals in your proportion. And we'll pretend for a moment that we didn't know that the answer was 15. If I cross multiply for this proportion, I get x squared equals 225. And then if I take the square root of both sides, I get x equals plus or minus 15. But we're only going to consider the positive answer here, so I'm going to say that x equals 15. Okay, doing the same sort of thing for example 2, let's pretend that they gave us the numbers 2 and 18, and they said find the geometric mean between the numbers 2 and 18. Well, what I would do is I would set up a proportion. I'd put x in the position of the means, which is along one of the diagonals, and I'd put the numbers 2 and 18 along the other diagonals. And again, I'd cross multiply. X times x is x squared. 2 times 18 is 36. I'd square root both sides, getting the x equals plus or minus 6, or in this case, just 6. And that confirms the idea from above. Let me give you a very quick third example. Let's say the question said, find the geometric mean or the mean proportional between 5 and 20. So I'm going to set up a proportion. I don't know what the mean proportional is, so I'm going to put x to represent that unknown mean proportional. I'm going to put 5 and 20 along the other diagonals. I'll cross multiply, getting the x squared equals 100. I'll take the square root of both sides, getting the x equals plus or minus 10. But I'm only going to consider the positive answer, which is 10. So if I stick a 10 right here, 5 times what number is 10? That would be 5 times 2. And then 10 times what number is 20? And again, that's times 2. So here are 3 cases where I've shown you how to find the geometric mean or the mean proportional. Now let's go to the actual question itself. This one, they give us the mean proportional. They say that 5 is the mean proportional. So in the first 3 examples, we were trying to find the mean proportional, but now they give it to us, and they say that 5 is the mean proportional between 20 and some other number. So basically, the setup is going to look something like this. We've got some number, we've got 5, and we've got 20. And 5 is the mean proportional between 20 and some other number. So this setup here translates into this proportion here. And now I'll cross multiply, and I get 20x equals 25. I'll divide both sides by 20, and now I'll divide by 5 on the top and the bottom, getting me 5/4. So the answer to the actual question in number 15 is 5/4. So when you're given a geometric mean problem, sometimes you're asked to find the geometric mean, which would be like examples 1, 2, and 3. And other times they give you the geometric mean and they ask you to find one of the outer numbers, let's say. So I hope this video was helpful, and now you should be able to do question number 15 from 8.1 from the text Geometry for Enjoyment and Challenge.